Okay, as requested by 2A, I'm going to go through the 5 questions in the solving similar triangles in algebraic situations section in your review. I'll try to make it as least boring as possible. But you're going to find all these problems in a very similar vein. They're very much about first identifying similarity, and then you too using the excuse me using the properties of similarity, mainly proportional side lengths and congruent angles, to solve for values. And that's what we got going on here. So the problem says to assume these are similar, which is good because if we couldn't assume that the problem's over, we can't actually solve it. And so right away, we have to notice a few things and maybe pick a few things out. So the first thing we have to notice is that this is lined up according to how I want it lined up. And that's simply because you can't assume anything else besides that. Otherwise, the problem couldn't proceed. So right away, what I'm searching for are two side lengths that are corresponding and are both numerical. Because if I don't have that, it's going to become a little bit tougher to solve the problem because I'd have to use like multiple proportions. Now, luckily, I have that. I have a 10 and a 30, telling me that the k factor is 3 if I'm moving this way, and of course, the k factor is 1/3 moving backwards. That's going to help in certain situations, and I'll show you a couple of varieties of how. Oh, whoa, whoa, a couple of varieties of how we can actually solve this type of problem. But first of all, let's just get the easy part out of the way. If these two things are similar, I know all these angles have to be congruent. So that tells me right away that y has got to be 50 degrees, w's got to be 70. This is really a gimme. X is going to be 150, and of course z is going to round off at 90. So that's the easy part out of the way. Don't forget about the angles too, because they have to play a part here. So let's just go around the horn. Let's solve for m first. So I'm going to go ahead and mark my work because that's what good students do. They always have to mark what they're doing. And so now let's think about m. So I have 2m plus 30 and I have 60. So again, there's a couple different ways we could approach this. I'm going to use the full definition of proportionality, knowing, and what I mean by that is if these two uh, shapes are indeed similar, their sides should all be proportional. So if I compare AD, which is 10, to its counterpart on the right, which is 30, so I just grab these two proportions, they have to be the same as 60 is to 2m minus 30. And that's what it means to be proportional. Like if I take pair of corresponding side lengths, they scale the same way. So the same way 10 to 30 is scaled, 60 to 2m minus 30 is scaled. Now from here, just pick your favorite algebraic solving method and do it. I'm going to go ahead and pick cross multiplication because I'm feeling crazy right now. So 60 and 30 steps should be 1800, I believe. And then solving the other way, I have let's see, 20m minus 300. So here's where we have to go ahead and continue solving. So again, show as many steps as you want. It's up to you. Let's see. So if I add 300 to both sides, that should be 2100 is equal to 20m. And then if I divide by 20, I believe m rounds out to be 105. Hey, so again, we're just using our definition of proportionality, using ratios, and guys, honestly, that will work for all the side lengths. I might vary a couple of them up just to kind of throw some spice in there, but that's all we're doing. So if I want to solve for n, which is right there, and I can use proportionality. Uh, I know that again, 10. Oh, so let's mix it up a little bit. Let's go backwards. So 30 going from the right back to the left, which is 10. Again, I'm taking advantage of that first ratio I know has to be right. Has to be the same as 9 is to 1 half n minus 9. So here's where a lot of people will make their mistake. They have to keep things aligned. So 30 is on the right, and then 10 is on the left. So I got to go right to left for 9 and 1 half n minus 9. It's algebra time, so let's get to it. Cross multiplying, that'll give me 90. Here's where I got to be careful because I do have to distribute. 30 times a half n should be 15n, and then minus 270. Okay. Let me grab my calculator just to make sure I'm giving you guys some accurate values. I add 270 to both sides. I get 360. And then divide 15 on both sides. I'll get 24. So n should be 24. Hopefully that's matching my key. Let's change it up on this one. And the reason I want to change it up is I want to present not just proportionality, but using k-factor as well. So I'm going to take advantage of moving left to right. If I take the value on the left, multiply it by 3, I get the value on the right. So if I'm going to solve for the b's, or just a b I should say, if I take the value on the left, which is 6b minus 10, multiply it by my k-factor of 3, I should get the value on the right, which is 7b minus 8. Now I could have used proportionality like the first two, but I want to kind of vary it up a little bit, and let's use k-factor for this one. So for now, we're just in algebra town. So like again, k-factor times side length equals image side length. So now let's just solve out. So that's 18b minus 30 is equal to 7b minus 8. Let's see, subtract the b, that should be 11 b's. And then add the 30, that should give me 22, so b should equal 2. Okay, so again, pretty straightforward, and the thing to kind of keep in mind is I was told these are similar right off the bat. If not, I'd probably do a little bit more work to ensure they are. Let's keep moving. So follow-up question. Determine and explain which figure is the original figure if the k-factor above is 1/3. Well, we kind of figured that out in our first step. 1/3 moves us from big to small. 1/3 being the multiplier implies the thing is getting smaller. So original figure would be EFGH. And I'm not going to write the whole thing out, but the k-factor of 1/3 indicates my object is getting smaller. All right, let's take a look at number 2. Okay. Solve for the unknown variables if possible. If it is possible, explain how you're able to take advantage of similarity. If not, explain why you weren't able to solve. In other words, explain how you couldn't prove they're similar. In this case, it's not an issue. We see the two triangles. Immediately, you should notice the right angles. That's angle 1. Here's a shared angle at angle 2 for both the little triangle and its big counterpart. So definitely the triangles are similar by AA. You should have that indicated somewhere on your paper. I'm just gonna clean that up. Okay. So now we just have to solve for some stuff. And again, I think I'm gonna do the easy stuff first, which is the angles. So if I have a 70 here, that means Z has to be 70. And if I have 70 and 90, that'd be what, 160? 70, 90, 160, which means W has to be 20. Okay, because 160 and 20 make that 180. So that's the easy part out of the way. Now solve for side lengths. I want to be careful here because I have a ratio that is set that I can use, 4.8 and 12. But I should note that 4.8 to 12, is a terrible choice, Mr. Collins. 4.8 to 12 is the entire small and the entire large length. So it's very easy to make this mistake. If I'm going to use the ratio of 4 to 8, I'm going to use the bottom of the small as to the bottom of the big. So whatever ratio I write on the right has to match this pretty carefully. In this case, bottom, bottom, small, big. So that means if I'm comparing, I got to compare small on top, big on bottom, and use the same part of the triangle. Here's what I mean. So if I got bottom small to bottom big, that means I have to use side small to side big. And that's going to help me in thinking in this way to pick out values. So side small is going to be 10. Now check this out. Side big is not x, and that's what a lot of people will write. That's totally wrong. The side of the big is actually 10 plus x. Okay? So go back and watch that again if you're not quite sure how I just pulled that off. Because the most common mistake people have made is have just an x on the bottom, and that'll totally throw you off. But it is a 10 plus x. So now let's just go into our algebra solve. So cross multiply, boom, boom. So I have 120 on one side. I'll have 48x plus, oh, excuse me, not 48x. Just 48, because 10 times 4.8 is 48, and that'll be 4.8x. Okay? So again, I'm going to use a calculator to solve. I'm no hero here. So if I take 120, subtract off 48, I'll get 72. And then divide both sides by 4.8 and get 15. So x is actually equal to 15. So I'm going to go and write that in. Okay, which tells me my entire side has to be 25. And again, that might come in pretty handy coming up here pretty soon. I'm going to run into a problem with the second one because I'm not given this length. Whoa, sorry about that. I'm not given this length, nor am I given the full length. And if I think about the ratio I set up before, I was comparing full lengths of triangles. Now, some people may think, well, now I have to stop. But that's actually not the case. The reason why is because you now have this entire side, which is 25, and you have this side, which is 12. So using Pythagorean theorem, I should be able to find AB, and I'll do that right here. So AB is the full length, the full left-hand side of the triangle, and we'll find it using Pythagorean theorem. We have 25 squared on the right, 12 squared on the bottom, should be equal to AB squared. Okay, so again, I'm going to use my calculator off screen here. So that's 625 plus 144 is equal to AB squared. So if I add 144, I get 769 is equal to AB squared. And then if I take the square root of that, see 769 square root, AB is going to be 27.73 about. So that's going to give me this length. Now that was useful only because I need now to set up a proportion to solve for y. So check out how I'm going to do this. All right. So I'm going to set up using a proportion on the right hand side of this, on the right hand side of the triangle. So I'm going to put the side of the small triangle is to the bottom part of the right. Should be the same as side of the small triangle on the left as bottom on the left. So I know that was a little confusing. Let me kind of explain what I just did. So the side of the small triangle on the right is going to be that, so 10. And then bottom on the right is going to be 15. Should be in the same proportion as the side of the right. Oh, I'm sorry. I messed it up. Oh, wow. Back up with me. Back up with me. Sorry, guys. I wasn't thinking. It's been a day. So let's kind of back that up. Okay. So I want to say a proportion. I just kind of forgot where y was. And the y is going to be on the bottom part of the left. I do have the entire left, and that's actually what's going to define my ratio. So let me try that again. I'm sorry for that. So the ratio I want to set up is the entire side of the left to just bottom of the left. And I'm going to compare that on the right to the side of the right, the whole side, to just the bottom of the right. Okay, so now when I start pulling values, hopefully just make a little more sense. The whole side of the left is at 27.73, which I just found. Bottom of the left is y. Side of the right is 25, the entire right side. Bottom of the right is just 15. So again, we're taking advantage of similarity in the sense that we can find proportions or parts of proportions. Man, that got messy, but that's okay. Now we're just solving algebraically, so I have 25y. Let's see, 27.73 times 15 is 415.95. Divide that guy by 25, and y should be about 16.638, approximately. And depending on how I round it, that might be different than the key, all right? That one ended a little messy. Apologies. All right. So same kind of thing. So if I can solve for the known variables, explain why. In other words, explain how I know they're similar. If I can't, I simply tell you I can't and move on. So the thing to note on this one is that we do have parallel lines, meaning that we have angles that are congruent because they're corresponding. And so that alone is enough to guarantee similarity because that means angle, angle. Now, if we want to throw another one in there, we could throw on the top. That shared angle gives us angle, 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 total overkill, but we could certainly solve for variables. So I'm going to go ahead and throw this into the mix. I'm going to solve a little bit differently than in my key, and that's because I'm going to set up proportions ahead of time. So the proportion I want to set up is top left to bottom left is the same thing as top right to bottom right. Is that the only one you can set up? No. In fact, you can set up a lot of different ones, but that's the one that makes sense to me. So top right, top left, bottom left. So that will give me x over x plus 5 should be the same as x minus 2 over x plus 1. Again, different than the key, but I want to show you kind of a different way to do this. Because they're proportional, the way this is arranged, I can take partials instead of wholes. So here, now we're just solving. So let's see, we have x squared plus x is the same as x squared plus 3x minus 10. And what I did there was just double distribute using what I used from Algebra 1. So 5 minus 2, that checks out to me. Now we get to solve, and here's some things to note. I have an x squared on both sides; they automatically cancel. Like, if you think about it, if I were to subtract x squared on both sides, those would be gone. So what I really just have left is a x is equal to 3x minus 10. Let's algebraically move this thing around. Let's move that x over here. Let's move the 10 over by adding. So x is equal to 2x, x is equal to 5. And if you check my key, that's exactly what I have, meaning that the method I use is not bad. The second one is going to be a little bit trickier because I have 3y and minus y plus 100. So I have the whole bottom of the small and I have the whole bottom of the big. I'm comparing whole triangles in this one, so I can't do partials. I actually have to do the whole triangle. So I just had to take a whole side and a whole other side. So I'll take the left of the small and I'll take the left of the big. Okay? So transferring values, I have 3y and then I have negative y plus 100. Left small is going to be x, and then that's going to be really careful here because I want the whole left side. That's 2x plus 5. So top and bottom added together. Now before we start freaking out, I'm going to point out that we do actually have values for x. So although this is still 3y and minus y plus 100, we just found x to be 5, so this should be 5 over 15. Okay. So now again, we're just going to solve any way we want, and it looks like I'm just going to do cross multiply again because I'm boring. So 3y times 15 should be 45y, and that's minus 5y plus 500. Big value. Okay, so move the 5 over, gives me 50 y's equals 500. That means y has to be 10. All right. So not so bad. Again, once we establish similarity, we off and running, and that's what we need. Okay, I'll get out of here. All right. So let's move on to number 4. So the divide diagram solve for the unknown angles impossible. Impossible explain. Okay, so let's just do like we had before. Let's see if we can actually meet similarity. So of course I have the angle here, and if you were not being careful, you'd say, "Oh, I have angles right here." But since you are being careful, you know that's complete garbage. If you're going to claim these angles are congruent, then I would ask you how you know. Now, if you reply because the lines are parallel, I would of course then ask you how do you know they're parallel? And the truth be told, you don't. You don't know they're parallel. If you don't know they're parallel, you don't know these angles are congruent. You don't know enough about sides to claim side, 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 or side angle side. So on this one, the answer is not enough information. Okay? You don't have the angles to mean angle, angle. You don't have the sides to mean side, side, side because they're defined by variables. And for likewise reason, you don't have enough for side angle side. So we're just moving on. All right. This one is one of those problems that seems a lot tougher than it actually is, but because you have to make a fundamental realization right off the bat, and the realization is you're looking at 3 triangles, and all those triangles are actually similar. I'll prove it to you. Now, if you don't see 3 triangles, pause the video and stare at this thing until you do, because I have a big triangle, excuse me, a medium triangle, and a small triangle. Okay, now, the reason I know they're similar is because everything is at a right angle. We actually have something here called embedded right triangles. This angle right here is 15. Now, think about the big, big triangle. If that's 15, that means this right here has to be 75. Okay, because 75 and 15 make 90, and then the 90 degree angle here is going to make your 180 degrees. But wait a minute, look at the small triangle on top. If that's 75 and that's 90, that's got to be 15. Right there, I've just proven the big triangle and the small triangle are indeed going to be similar because of angle, angle. I have 75 and 15 in the big triangle. I have 75 and 15 in the small triangle. They're going to be similar. Now, one last step is to think about this medium triangle, the one on the bottom right, if you would. There's 15, there's 90, that means this is 75, meaning that I have 3 triangles that are all similar to one another. So if I need to solve, and please take note, solve means find all missing pieces. I've actually just solved for the angles, and I'm not going to take any farther than that. I'm not going to rewrite them. They're right there. All the angles are solved. They're all 90, 75, or 15. I do want to make clear, though, that I am trying to solve for other side lengths. So I do need to find, I'm going to label these. I'm going to find that x, I'm going to find that y, and I'm going to find the z because the z is going to help me find this full length. Now, one thing that makes this very confusing is that all the triangles are one on top of the other. So I'm going to take the tactic of writing them all out. So I'm going to line them up on the right, rewriting them crudely if that has the way it has to be, and then relabel it. So I have 8 right here. Let's see, that is y, and the bottom is 20, and I took that from this triangle, small triangle right there. Okay. Let's draw a medium next, and here's where your spatial ability is going to be tested, because I have to do kind of a rotation here. But once I do rotate, okay, I'll find the side here is 20, the hypotenuse is x, and the bottom side is z. Now, I don't know a lot about that triangle, but it's probably going to come in handy. It usually always does. And this one I have to do like a reflection left-right for the big one. Okay, so I have y on the side, I have 8 plus a z across hypotenuse, and then I have x on the bottom. So what I'm looking for to solve these, again, knowing that they're all similar because of the angles, I know angles involved, is I have to selectively pick things to solve. Um, but really what I'm looking for is like a Rosetta Stone. And what I mean is there a triangle in this bunch in which I know all the side lengths right now or could easily find all the side lengths? The answer is yes. Look at this guy right here, little guy. Guy no one saw coming over here. The little guy only has one unknown piece, and it's that value of y. It's a right triangle. I can use Pythagorean theorem. So if I have 20 squared, which is 400, and I add 64 to it, I get y squared. So if I add those two pieces together, I get 464. And then if I square root that, and I'm going to have to round here, which kind of sucks. The y value is 21.54. Okay, so that's an approximation, of course. So do you guys see why you have to be good at Pythagorean theorem and distance form and all that? It's not for that in itself, it's for stuff like this. Now, if y is 21.54, that means this is 21.54. Because again, these are all embedded triangles, so if I find one value, I'm usually going to find more than one. But that gets me, I think, a little bit closer to where I need to be, because now I have a triangle for comparison. So now the question is, what do I want to find next? And I probably have to find these in pieces, meaning I'm not going to find X, Y, and Z in one big foul swoop. I'll probably take it a little bit slower than that. So I'm going to focus on these triangles, and I think I'm just going to try to find X. Okay? And here's where we got to line up the pieces really well. So if I want to find X, which is the hypotenuse of the medium, I need to compare that to like parts in other triangles. So maybe the hypotenuse of the small. So medium, small, same part is my ratio. So now I'll find a ratio of both triangles that I also know the parts, and it turns out the side on the right. So if I take the right of the medium, it's going to have to be the right of the small. Notice again how medium's on top, small's on bottom, and then I have the same parts left and right in my proportion. So now when I fill this in, I can have confidence. The hypotenuse of the medium is x. Hypotenuse of small is 21.54. The right of the medium is 20, and that's going to be the right of the small is 8. So that should allow me to solve this proportion actually fairly quickly. So cross multiply, 8x is equal to 430.8. And of course, we're approximating at this point because I've already rounded. And x should be equal to 53.85. All right, so if that's 53.85, that means that is 53.85. And I think I'm almost home. Like, again, not too tough a problem once you break it all apart. So now you need to find z, and I think I'm just going to use these two triangles to do it. I don't think I even need a large triangle at all. So z is on the bottom, so bottom of the medium is to say the side of the medium, because I can write any ratio I want, so I'm going to keep within the same triangle. So I have to write a bottom small, side small to match it up. So bottom medium is z, side medium is 20. Bottom of the small is 20, and then side of the small is 8. Okay, I'm using those two triangles right there. Now it's algebra time. So I have 8z is equal to 400. cross multiplying, right? So if I take the 400 and divide by that 8, I get 50. That makes z equal to 50. I'll write that in. It's 50, and that's 50. So I go back to my original triangle and pull those values. I now know this entire side has to be 58. The x value, where'd you go? X value is 53.85, and the y value is 21.54. Not nice numbers, but guys, it's math. Not all numbers are nice. So that was a long section, guys, but you asked me to go over 5 problems. So, of course, I'm going to put them in the same video. I do have a request to go over number 1 and number 2 on the context, and I will shoot that video right now and post it. So that's what I got for you guys right now. Let's stop this crazy machine. All right.